Okay, everybody. So what we're going to be looking at today is programming assignment number 2, searching and sorting plus some sequences. So what this is based on is, what is it based on? This is basically section 3.1 in your book, and also section, I want to say 2.4. Now, we didn't cover 2.4 yet. I wanted to cover 3.1 before I went back and did 2.4. So we're doing those out of order, but that's what this programming homework is going to cover. Okay, so I think mostly we're going to talk about section 3.1 today. But yeah, so let's go ahead and get started. So of course, if you're looking for the programming assignment, where you're going to need to look is on the course website, which I'll open now. Oops, not there. Where is it? Here. So this is lecture for week 7. That's not what we want. It'll be in week 8. So as soon as I upload it, it'll be right here. And yeah, so let's take a look at what you're going to get. So in the programming assignment, what you're going to find is basically this zip file. So programming homework 2, fall 2020. Okay. And just like for the first programming assignment, you're going to need to extract that somewhere. Okay. So in Windows, you should be able just to right click and find somewhere on here, it should say like extract all. Because I have 7-zip installed, I don't really see the default Windows option anymore. But 7-zip can extract it. So I'm going to extract it into a folder. So extract to programming homework 2. That's fine. Okay. And so now I've got this folder here, programming homework 2, which if you look is in my C drive, users, Greg, Octave, programming assignments, programming homework 2. Now, why is it there? Because that's where I put the file, right? You can put this wherever you want, in documents, downloads, wherever you want. But you're going to need to know where you extract it because you need to be in the right folder when you're going to be using MATLAB. Okay. So there you go. So inside of this folder, you've got some M files that I wrote for you. So insertion sort, linear sort, and sequence plot, I did for you. Okay. And then you've got the PDF for the assignment, and you've got the tex file. The next one's the tex file. And then you've got this extra file that you need if you're going to use Overleaf to write your write-up. Okay, so we may as well get that started now. So if I'm going to use Overleaf to write for the write-up, then I should have Overleaf open, right? Overleaf.com. And I need to create a new project for my homework. I'm going to go to new project right here, click it, and you can just do either a blank project or upload project. Upload project's probably the easiest, so I'll click that. And it says select a zip file or drag a zip file. So I'll go ahead and drag it. You could browse for it, but so this is just, oops. This is the same folder I was in before. So I'll back out here, and this is the zip file that I just extracted. Should be fine to upload this. There's some files in here that you don't need for Overleaf, but you know, whatever, it should be fine. So I'll just drag this here. There we go. It found the tex file. It should be compiling it. And it's smaller here. It's bigger here. And there you go. So now I've got project in Overleaf, right? So just like homework 1, you've got the PDF over here. You can go through it. And also we can type in here, right? So if this is your write-up for your homework, first of all, you need to get your name in here. So in the source code over here, just the way everybody uses LaTeX, by the way, is you have one LaTeX document that you got from somewhere. Like in your case, I gave you this LaTeX file, right? But where did I get this LaTeX file? Well, look at the stuff that you see in here. You know, let's do some investigative journalism here. Declare math operators. These are for making things look nice, like the word argmin exp, grad, log, etc. I've got commands for if you actually ran one of these are for doing like ddx, like for calculus, ddx, um, d squared over dx squared, that kind of thing. So why are these all here? I'll tell you why they're here. They're here because I use the same stupid LaTeX file for everything, right? Whenever I learn something in LaTeX, I type it in here and then it's here forever. So every document that I write from now until the end of time is going to have all this garbage at the top, just in case I need it. Okay. And so let's scroll past all the garbage that we don't need to care about to the actual document, right? So the document starts somewhere. I can see left heading, center heading, right heading, which is what you see up here, right? Left heading, center heading, right heading. And then you can see begin center, bold-faced font, homework 2. So there it is. So you need to get your name around here somewhere, right? So how would you do it? You just write name, name. We don't have a format that we have to follow. If I want, I can put the due date here, which, by the way, I'm going to make this due next Friday. A week and a half, I think, is plenty for this. I want us to get, on track here and be doing some work. Now, something you're going to see, I'm going to compile this and then I'm going to show you something over here. So hit recompile, right? Recompile. Notice that it says name, Greg Hogan, due, or I should have said date, 10/16/20. And it put them on the same line, even though they're on different lines here. That's because LaTeX assumes that, just because you went to another line doesn't mean that you want to go to another line. Maybe you went to another line because you ran out of horizontal space. So they don't assume that you want a blank line unless you actually, or to go to a new line unless you actually leave a blank line. So you'd have to type it like this in order to get them on separate lines over on the right-hand side. Okay. That's just in case you were wondering. So I put my name on there. That's a good idea to put your name on there. Well, of course it's a good idea, but the reason you want to do it is because you want to make sure that you can tell the difference between the original LaTeX file that I gave you and your copy, right? Fix some typos while we're going here. So yeah. All right. Anyway, so we know something about how to do this. So just to take a look briefly here, I guess I'll make this bigger to make it easier to see. Fonts aren't great here, but let's see. So you'll notice that like problem 1 here says look on Blackboard. Oh wow, how long ago did I write this, right? We don't use Blackboard, we use Canvas. Okay. Space. So look on Canvas for the code in files that we made in class for linear search and insertion sort. So we haven't actually done insertion sort yet. We're going to be doing that today. But you're going to have the code, and then using the code as templates, do the following. We're going to code up the binary search algorithm, which is in section 3.1. I tell you how to start it, and I want you to name it this way, DS binary search. And the reason I want you to do that is because if you like, the DS is for discrete structures, this class. And I'm just putting that at the beginning of any of my functions. And that way, in case there was some other binary search algorithm or something built in, we wouldn't be conflicting with that. You're running this one because of the DS at the beginning. Same thing with bubble sort. We're going to be coding up bubble sort. And yeah, and so those are going to be the first line of your code if you follow my template here. And if you look at what you have to do, you need code in the write-up. This is the write-up. So I'm going to actually, like it says function L equals DS binary search right here. But once I actually have the code for binary search, I'm just going to find that, which is somewhere, line 110, it looks like. Maybe different by the time you get this. But right here, line 111, I can just replace this with all of my code, right? Or I can put another block down at the end of this. But this is where my code's going to go. Code goes in here and also as an im file. So it's 5 points for each. So if you give me the im file, but you don't have your code here, then you're going to lose 5 points. And if you put your code in the im file, or sorry, in the document here, but you don't include the im file, you're going to lose 5 points. You have to have it both places to get that full 10 points. And the reason for that is very simple. The reason you have to do that is because I need to see it here so I can look at it and see if it's correct. But I also need the im file because if you don't give me the im file, first of all, I don't know if your im file ever worked. Like, did you actually put it in an im file or did you just type it here? And that's one reason. And the other reason is if I have a question about whether or not your code works, then, I need to run it. And I don't want to have to copy paste stuff. I just want your file and I'll run your file. Okay. So that's why it has to be in both places. So let's make a note of that actually. So be sure to include im files, in the zip, in the list of files that you turn in. So be sure to include im files in the files that you turn in, and also include the code in your write-up. Okay, very important to do that. All right, so let's come back here. What else can I say about this before we get started? Oh yeah, another thing that's very important. You're going to be using or doing this based on the algorithms in the section. Okay, now I know that you took another programming class before, right? And I know that you probably covered bubble sort and things like that in that class. You can't use that code. You can't even use that algorithm. You must use the algorithm in our book. So no code or pseudocode from anywhere else. All right, so you're going to be coding up our algorithm the way that we wrote it. If you don't, I'm just going to give you a 0 on it. And yeah, I know that's harsh, but the whole point is that this is our programming class where we're doing our programming. And if you use your code or algorithm from somewhere else, then you didn't do this assignment. You just did that other assignment again. Okay, so our algorithm from our book, which I will point you to momentarily. Okay, and that's for all of these. Yeah, and actually, I think that's it. I think we can go ahead and get started now. Okay, so what we're gonna do is it says look on Canvas for linear search, insertion sort. So we're gonna get started doing that. So I think we actually did linear search in one of the previous lectures. So I have my last 2 lecture notes here. So this is section 1, or sorry, part 1 for section 3.1. Let's see if we did any code here. That was find a maximum, linear search. Yeah, so linear search, we wrote the code here. Did it run? I don't know. We didn't actually do it, right? So let's go to MATLAB and just try to write this, and we'll see how it goes. So I've got MATLAB. Oops. Here, make this short, fit on the screen. Oh wait, I can do this. All right. So first problem, I'll say problem that we have. Can I move this? Is that something that can happen? Yeah. Okay. So the first problem here is that I'm in the wrong folder, right? So you have to get in the right folder. So wherever you extract your programming assignment, so in my case, programming homework 2 right here, right? This is the folder where my stuff is. I need to be in that folder so I can do my work. So what I'm going to do is I'm going to click up here in the bar I'm just going to get that entire path. I'm copying it right now, Control C, and then I'm going to come up here and I'm going to paste it here. Now I could find it because I'm actually in a higher up folder, but maybe you're in a completely unrelated folder when you do this. So just going to paste it right here. There we go. Hit enter, and there we go. Okay, so this is my folder. Now, what is this right here? This is some leftover code that I was doing something with. A digital filter, a digital low pass filter for a Super Nintendo emulator type thing. All right, so we got MATLAB right here. So what we're going to try to do is we're going to try to write this function linear search. Now, I already wrote it right here. Let's open it up. Actually, let's not. Let's delete it. Let's delete that file. Okay. I'm going to write that from scratch, right? Let's make it work the way it works here. So what is this? Okay. Okay. Get that on the screen. So I'm using MATLAB for this. You could use Octave, of course. I'll use Octave for something else. So we need a new function, not a new script, a new function. But I'll just click new script. That's fine. Got an empty document here. And this is the code that we came up with 2 lectures ago. So let's just see if it works. Function, location. And the function here was called, look, linear search, but I'm going to call it, what am I going to call it? Let me scroll down. Actually, no, let's look here. Whoa, can't see it. Let me find, life is hard, guys. All right, let me open that. Okay, so are we going to run linear search? Do we run it anywhere? Do we run it anywhere? Okay. I guess we don't. So we don't even need linear search for anything here, but let's go ahead and code it up anyway. I was just going to verify that we were, making the format correct and everything, but it looks like that is not needed. All right, let's code it up and just double check that it works. All right, so I'm going to call it DS linear search, and it's a searching algorithm, which means there's one variable called X, which is what we're looking for. And then there's the vector that contains, or that we're searching in. So my 2 input variables are X and A. And something that we haven't talked about before in this class is when you have a function like this, if the next line or the next 2 lines or whatever it is, you can make comments. So comments in MATLAB are done with percentage sign. That's a comment. Not that. We're looking for percentage sign. And if I type anything here, it's actually pretty useful. So like, what is this going to do? I'm going to say DS linear search X A. What does it do? Searches the vector. So I'm telling you it's a vector A for an element X and returns can't type. Returns the location in A that it found X. And it returns 0 if X is not found. Right, so there's my description of my function. Okay, what else? Also up here, looks like I forgot an equal sign. There we go. Oops. Okay, so you'll see why I did that in a minute. Actually, I can just go ahead and do it. Type ind, go into the function, save it, ds_linear_search.in, save. And down here at my command prompt, let me do something. So we can't run this function yet because it doesn't do anything, but watch what happens if I type help ds_linear_search. So I type that and hit enter, and look what it does. It returns, like, the text that I just typed is the help text now if you type help. Okay, so if you have a description of how your code is supposed to work, you can put it up there, and that will be the help that a user can see if they type help and then your function name. So that's just a nice thing that you can do. Okay, now let's go ahead and get started. So first thing you might remember from before is that most of the algorithms in this section refer to n, where n is the length of a vector. But we don't have n being passed into this function, so you calculate it. So n is length a. I'm going to use semicolons on the end of commands. That's not required, but what it will do is suppress the output so you don't see it on the screen. Okay. Then we got I equals 1, semicolon, we don't want to see it. And then I've got a while loop. So while parentheses I less than equal to n and x not equal to I equals I plus 1. End. Okay, so there's a while loop. And then after the while loop over here, we've got an if else statement. So let's write that. If I less than equal to n, then the location is I, semicolon, else location equals 0, end. Okay, there you go. So I saved this, and that's the code that we wrote in the lecture, and it should run. Now, something else is when you're writing code, you might not get stuff indented properly, right? And MATLAB won't really care, but, it's bad to write it like this, for example. This would not be a good way to write it. But something you can always do is I don't even think you need to do that. If you right click and there's somewhere where it says Smart Indent, and if you click that, MATLAB will just try to format your stuff for you. I guess you do have to select it. Select all. Hey, select all, right click. Smart Indent. Okay. Oh, well, I guess it didn't hate it anyway. But anyway, it's nice that you can get MATLAB to do that. Octave cannot. So in Octave, it's up to you to keep the formatting nice. All right, so there we go. So we wrote this code. Does it work? Let's find out. So the way you would run it is, well, first of all, you need a vector to search in. Now you can code it up, right? Like I can do like v equals, and I can just make a vector 3, 5, 7. That's a 3, 5. I need to stop doing the same numbers. Right? So there's a vector. Okay? And what this function is supposed to do is if I call the function, so ds linear search, tab is autocomplete. So you see I typed part of the function name. I'm going to hit tab and it knows what it should be. And so if I look for a 3 in the vector v, so I'm going to pass in a v, then what should it tell me? Where's the 3? The 3 is in position 1, right? So this should return a 1. Hey, it did, right? Now if I type in 11 and run it, what should it return? 1, 2, 3, 4, 5, 6, 7. So it should tell me 7. All right, tells me 7. Okay. Now, when you're testing a searching algorithm like this, it's a good idea to make sure that it can find the first number in the array and the last number in the array. Because if you're off, like a common mistake is like you have like less than or equals. Well, what if you did a less than? If you accidentally did a less than when you meant less than or equal, then maybe you would only be able to search to the 50 and you wouldn't actually get to the 33 or something, you know? So when I'm testing this, like I would go like, okay, well, we know it found the 3. We checked that. Would it find the 33? Yes, it does. Okay. And the other thing you need to check is, can it find things in the middle? Yes, we saw that it did. What about this? What about the else location equals 0? It returned 0 when it did not find the number. So if I run this function and I give it a number not in here, so what number is not in here? Like 20, right? 20 is not in here. Try that. So it should tell me 0 because there is no 20. Okay. So there you go. This looks like a functioning linear search. Okay. Um, let me, what do I want? Let me open Octave as well just to double check this. Octave. Okay. So let us find, well, again, the same folder. So here's MATLAB. Let me get the folder up here. Let's go here. You can probably do it up here or down here. Paste it, enter. Okay, so we're in the same folder. Let's just check that our linear search works. Oops, typing in the wrong place. Type here at the command prompt. All right, DS linear search, tab autocomplete still works. In Octave, actually, let's Control C this. Let's make a new vector, a different vector because I don't want to think about the other one. Really? 39, 20. Okay, now something I do want to mention about this is that if you actually look at the definition of the searching algorithm, it'll tell you that you can only have one of each number in here. So like I have a 6 and I have another 6. Well, it's never ever going to find the second 6. It's only never going to find the first one because it just goes one by one. So it'll find the 6, but it won't know that there's 2 of them if I run it. Okay, so there's a vector. Let's try to find something in here. DS linear search. Let's try to find a 3 again in vector V. Okay, found that. Let's try to find a 20. 20 is in this vector, so it's 1, 2, 3, 4, 5, 6, 7, 8. So it should tell me 8. Of course, that works. Find a 6. Tells me 2 because it found a 2 right here at the second element. It's never going to get to this one because it stops after it finds it. Okay, so found it in the second element. Of course, if I give it a number that's not in here, 50, it tells me 0 because there's no 50. Okay, so again, it still works. I'm just verifying that the code works in Octave as well as MATLAB. I'm a little bit worried that one of these functions doesn't. So we'll find out. Actually, we can try it. I have this insertion sort here. Sorry, DS insertion sort. V. Okay. Does it work here? DS insertion sort V. Okay, works in both. That's good. So we're going to write code that hopefully will work in both as well. Cool. So got Octave, we tried it out. Again, make sure you're in the right folder. We had MATLAB, try it out. Again, make sure you're in the right folder. They both work fine. Everything's good. Let us go back to our homework, which is somewhere. I will Alt Tab until I find it. Oh, here, it's skinny. That's why I couldn't see it. Make that bigger. Okay, so come on now, click small. Okay, so our actual, no, we're not doing homework yet. What we're going to be doing is we're going to code up insertion sort. So in the second lecture here, what we covered was, let's see, this. So algorithms part 2 lecture, we covered searching and sorting. We covered the binary search, which we went through and we did by hand. So remember how binary search was supposed to work? You start out with a big list, you split it in half, you throw out half and keep half, and you just keep throwing out half until eventually you're down to one element. And when you have that one element, you say, well, if that's what you were looking for, then good, you found it. If that's not what you were looking for, then bad, you didn't find it. Okay. Um, you have to code that up, not me. So this is the code that you're going to code up. So you're looking for the binary search algorithm. This is what you need for um, the homework, right? Where's the homework? Here it is, right? Binary search. You code that up, not me. Okay. Now, after we did that, we talked about sorting. So we covered bubble sort. Again, we did it all by hand. And this is bubble sort. Bubble sort is not that long. It's literally one, two, I would say it's more lines than it looks like, because if then goes on 2 lines, and then some lines are just end. But you code up bubble sort. I code up insertion sort. So we talked about insertion sort right here. No, I'm not opening. I'm not updating NordVPN. Remind me later. Okay. Um, and then we talked a little bit about insertion sort, which was a different algorithm. Now, even if I don't understand how insertion sort works, I can still code up this algorithm because I have pseudocode for it, right? I know what it's supposed to do. I know it's supposed to sort numbers into order, increasing order, and I've got the pseudocode, so I should just be able to code it up. Okay. Now, what we're going to do is we're going to do just that. Okay. So we talked about it a little bit. Now we're going to code it up. So insertion sort. So let me close a linear search. I'm going to delete insertion sort because we're going to code it up from scratch. And let's do this. So what do I need? I need a new function, but I'm just going to click new script. And how am I supposed to do it? So if I look at the homework here, well, actually not the homework, right? DS insertion sort. You want to make sure that you match the like uppercase, lowercase nature as well. So here's how it's going to be. It's going to be function, calling it DS underscore insertion sort. Wait, am I? No, I think it's like this, right? Yeah. It's sorting. So when you're sorting, you only need one input. Okay. And also for output, you need one output. Okay. And you can actually output an A even if your input is A if you want. Okay. And the way this algorithm is written, it is just modifying the numbers that are in the original list. Okay. So input is A, output is A. So what does this do? Again, I can say what it does. This is going to sort an array, which in MATLAB is a vector of numbers into order. What else does it say? It says n needs to be greater than 2. Let's just say that just so they know. Let's see. Vector length must be 2 or more. Okay. Now let's go ahead and get started. So yeah, let's go ahead and get started. what's the first thing we need to do? Well, again, the numbers go A1 through AN. N is how many of them there are. So the first thing I'm going to do is n equals length A. Now, I don't know why I did this, but in the homework, I used an uppercase A. They use lowercase a's here. I don't actually care. So if you want to change them to lowercase a's, go ahead. It doesn't matter. So uppercase, lowercase, whatever you want, just be consistent. So I just changed it to lowercase. All right. So let's go ahead. So n is length A, so I've got n. Now, it says n is greater than 2. You don't have to do anything special to check that because they didn't do anything special to check that. If they didn't put it in the algorithm, let's not bother, right? I program like a mathematician. We don't do checking input for correctness. You know, you're smart, give it correct input and it won't crash. Okay, so let's go ahead and try to code this up now. So what do we do? Start here. 4j equals 2 to n. Okay, 4j equals 2 colon n, right? So notice the difference in how they write it and how we write it. You can't just type what you see. You have to translate it into MATLAB. Inside the for loop, we've got I equals 1, right? Colon equals, according to them, is assignment. So that's just a regular I equals 1 over here. Semicolon, we don't need to see the output. Then it starts a while loop. While aj greater than ai. So new line, while, what do we want? aj. Remember how you have to type aj, right? It's parentheses, not subscript. There's no subscripts in MATLAB. So aj greater than ai. Now, something that you may ask is, well, while aj greater than ai, I can see that. Does this need parentheses around it? Actually, no. In MATLAB, you don't need parentheses around a statement like this. But I'm going to go ahead and put them, and that doesn't hurt anything. So map my while. While aj greater than ai, I equals I plus 1. Easy. I equals I plus 1. Semicolon. All right. So back over here, this I equals I plus 1 is indented, but the next one is not. M equals aj is not indented. That means this M equals aj is not inside the while loop. The while loop only has this I equals I plus 1, and then this is next, after the while loop concludes. So up here, when I'm trying to code that, after I do the I equals I plus 1, that's it, done with the while loop. When you're done with a loop in MATLAB, you have to write end, right? They don't use end over here. You have to use end over here. So that concludes my while loop. The next line is M equals aj. So enter M equals aj, semicolon. If you leave it off and go to the next line, you'll see that like MATLAB wants to highlight the equal sign. And if you hover the mouse over it, it says terminate statement with semicolon to suppress output in functions, right? So it doesn't matter, but they suggest that you put the semicolon so you don't output random stuff here that you don't want to do. Okay. After that line, we start another for loop. For k goes from 0 to j minus I minus 1. Okay, it looks complicated, but you know, we don't have to think about it. We just have to type it. For k equals 0, and instead of 2, you use a colon. K equals 0 to j minus I minus 1. Good idea to use parentheses here, j minus I minus 1. This makes it easy to read, and I don't think I need a space there. I like it like this better. All right. So there you go. What's inside the for loop? This one line. So the next line is this. So enter. Inside the for loop, we have a j minus k. The j minus k is inside, is what element of a we're looking. So that's actually a parentheses j minus k for the j minus kth element equals, what's it equal? A j minus k minus 1. So over here, a j minus k minus 1. Oops. Semicolon. All right. Now, that one line is all that's inside the for loop, right? I know that this AI line is not inside the for loop because if it was, it would be indented to line up with the one above it. So this line is not indented, so it's not in the for loop. So that means the for loop is done. So you have to end it with end, enter. And what's left? Just this, AI equals M. So you go AI equals M, semicolon. And then it says the numbers are now in increasing order. So we must be done with our function. So I'll go ahead and put an end. Oh, actually, I need that end, right? Because that's the for loop. Everything here is indented. All of what we just did is inside this first for loop. So this end, right? Did you see how when I typed it, it highlighted the for up here, right? So that ends the for loop. So then what you could do is you could end the function by one more end. If you leave that off, it actually is okay, but try to put it in. So the end ends the function. So there you go. So this is just an exact literal translation of the pseudocode. And basically you have to do that twice yourself in the homework. Okay. So, what's in the loop, what's not in the loop, make sure you end them correctly. What's the correct syntax, all that kind of stuff you have to pay attention to. But other than that, it's really just one line to one line almost. Okay, so we typed up the code. Do you think it works? Well, I guarantee it doesn't because I changed that to a lowercase a, but I forgot to change the output to a lowercase a. All right, so now they're both lowercase a's. That should be fine. I'm going to save this. Save it as the correct name. Remember, the file name and function name have to match. Okay, so I've got an insertion sort here. Does it run? So if it runs, it should be able to sort an array into order. So let me make an array, just any array that's not in order. Okay, so there you go. There's an array. It's not in order, right? You got big numbers at the beginning. I repeated a lot of numbers. That doesn't matter. So let's try to sort it. So if I sort it, I just need to pass that into the function. Notice that my vector here is called v, but in the code it was called a, and that doesn't matter, right? Because the a is a local variable to the function. It doesn't have anything to do with what you have outside of the function. Okay, so let's try this. So insertion sort v. Look at that. 1, 2, 2, 4, 4, 5, 6, 6, 7, 9, 9. It's in order, right? That's what we wanted. So it appears to work. Now, another thing they said is insertion sort real numbers with n greater than 2. What happens if you try to sort something with just 1? It's actually fine. So I guess it actually doesn't matter whether you put one thing or more than one thing in here. It seems to work fine. So yeah, so we did it. We coded up insertion sort. Now that's not your homework, right? Your homework is says, look on Blackboard, not Blackboard, Canvas, for the files we made, linear search and insertion sort. And then it says, use those as templates, do the following. You're coding up binary search and bubble sort, which are easier. Like binary search is shorter than this, or maybe it's about the same. Bubble sort is definitely shorter than this, though. Okay, now something else that you have to do next. So I'm not going to cover those algorithms specifically right now because we did it in the other lecture, but I do want to talk about this in the homework. I say, now that you have implementations of bubble sort and insertion sort, please do the following and report your results. So it says 10 points, code an M file plus results. You don't have to put your code here because I typed the code for you, right? So you're not actually coding anything for problem 2. Okay, you're running a script that's going to time the code execution. Okay, so what this does is it says use tick and talk to time the insertion sort. So here's what's happening here. So let me show you. If I type tick, right, nothing appears to happen. But what happened is a clock is now running. And whenever I want, I can type talk. And it tells me how long was between the tick and the talk. Okay, so whenever you want to test how long something takes in MATLAB, all you do is you put a tick at the beginning and a talk at the end. And also see how the talk does not have a semicolon? That's because tick, it doesn't matter. But talk, if you put a semicolon, oh, it's actually fine. I thought that it would not display. I think maybe it doesn't display an octave. Let's see. Tick, talk. Whatever. So I guess it doesn't matter if you have a semicolon or not. I don't know why I thought it did. All right. So anyway, what this is going to do is if you look at this code, let me just actually, I want to put this into a script. So I'm going to click, let's do it in Octave actually. So I want a new script. So file, new script. Here it is. And I want this code over here. Now, I told you this before, but I'll tell you it again. Don't copy, paste from the PDF into here. Well, first of all, it's not even working. But it's a bad idea because this is formatted text and it might use characters that are not just normal text characters, okay? So if you have to copy paste it, you should do it from the LaTeX file. Like if I scroll down, I can find it. Here it is. So you would want to get it from there because that's just raw text. Okay, so all this is going to do, what's going to happen? So this first line here, v equals rand 1 1000, creates a 1 by 1000 vector of random numbers. So let me click over here to command window down here. So like if you do rand like 5, you might think that's generating 5 random numbers, but no, not in MATLAB. If you type rand 5, you get a random 5 by 5 matrix. Remember, MATLAB is matrix laboratory. So if you want a vector, it's not rand 5. It would be rand 1 by 5 to get 5 in a row, or rand 5 comma 1 if you wanted 5 in a column. Okay, so don't just put one number into rand. So that's what's happening here. 1000 random numbers. After I have 1000 random numbers, I'm going to tick to start the clock, sort the list, semicolon, because I don't need to see 1000 random numbers on the screen, so semicolon, and then talk to stop the clock, and it will provide results. Okay, so I'm going to save this, call it whatever you want. So I can call it like problem to, time script or something. I don't know, 2A, whatever. I call it whatever you want. Doesn't matter. Something.in. Okay, problem 2. Command window and run it. Oops. So I can either type it, problem2_A. You don't type the .m here, just problem2_A. See how long it takes. 2 seconds. Okay, let's try it again. Now, what happens in Octave a lot of times is the first run is slow, and then if you run it a few times in a row, it gets faster. This depends a lot on how fast your PC is, by the way. Now, MATLAB tends to be a lot faster at these, but let's see. Where's MATLAB? Here's MATLAB. Let's try it. We can run the same script. prob2_a. Yeah, see, that's much, much faster. Interesting, actually, that it is so fast. I wonder why. Some stuff is not faster, by the way. Like, you can't just say, oh, MATLAB is much faster than Octave. It's actually not true. Like, a lot of linear algebra type stuff might be faster in Octave. It'll depend on what math libraries you have installed. You can install like special math libraries that people have been writing since like the 1970s, just designed to run linear algebra problems really fast. And Octave can use those, and MATLAB can too. And so you can make one faster than the other pretty easily. But this code just ran slow on Octave for some reason. Yeah, but it ran, so that's fine. So that's the kind of thing you're doing. But I say that's the kind of thing you're doing because it says, time insertion sorting with 500 and 1,000 entries. Do this 5 times and report the average. So you can do this. You can literally just run it 5 times, right? Like I've already ran it 3 times. 4 times, 5 times, right? So I literally ran it 5 times, and I can just average those numbers by hand. You can get clever. So like, first of all, it's perfectly acceptable to do that. So like on problem 2, let me write this. Oops. On problem 2, you can average those numbers by hand. If you want. Or you can write code that does it, right? I don't care. Okay. So how would that look? So if I wanted to write code to do that, run it 5 times in a row, what I could do, let me find Octave editor. What you can do is, instead of just having these commands all right here, what you can do is you can make a for loop for I equals 1 to 5. Okay. And then put all this in the for loop. Okay. And then what you can do is you can put your times, like talk returns the time, right? So like when I ran talk, talk prints this on the screen, right? But what we didn't talk about was if I do this, like tick, and then if I go like x equals talk, and then type x is 4.9998. That's how long, like that's the number of seconds. And now it's in a variable. So what you can do is you can make a for loop that'll do this 5 times, and then you can save the time, like you can write like ti equals talk. And if I save this now, save, I'm down here, and run that script, it takes longer to run, first of all, because it's running 5 times. So I have to wait. and wait. I mean, it should be like 15 seconds, right? And you can see you've got a new variable called t, and that t is all the times. So if I type t, they're all right there. Those are the times. But then what you can do, you need the average, right? Mean t. Mean is average. So there you go. And so that would be the clever way to do it. And then at the end, you could do like printf average time is %d seconds, \n in there, comma, mean t. Save it. Now if I run my script, let's see. Is printf right in octave, or do we have to use fprintf? Let's find out. No, that's fine. So there you go. Average time is there. So that would be the sort of quote unquote clever way to do it, where you put them all in here. And you've got to do this for 500 and 1,000 entries. If those don't give you good times, feel free to change them. As long as you do 2 times, I don't care. But tell me what you did. So like if I'm in octave and this just runs too fast, so like in MATLAB, if I do run this in octave, oh, come on now. Problem 2a. fprintf. Run. So like that's a really small time. So if I'm in MATLAB and I don't want the time to be that small, maybe I don't want to use 500 and 1,000. Maybe I want to use bigger numbers. So maybe I'll use 10,000 if I'm in MATLAB. Oops. To run it now. That's still faster. Do 100,000. MATLAB. Why not? That's weird, actually, if you think about it, because um, if this was 10% of a second, and we just increased it by a factor of 10, so it shouldn't have been 1 second. How come this is taking longer than 1 second? That's crazy. How big is t? Oh, t is already. I was going to see if we could tell how long we were doing this based on t. It has not even finished it once. I'm going to stop it. Oh, okay. Average time 9 seconds. Okay. I added 1 0 and it took a factor of 100. Oh, duh. Sorry, I wasn't even thinking. I said I increased this by 10, and then this increased by a factor of 100. Yeah, I think that's how it's supposed to do, right? This is not an efficient algorithm. Okay. Duh. All right. Anyway, so that's the clever way to do it. fprintf should work in both. Now I just saved it in MATLAB, so this has got old code. Okay. And fprintf should work in both, I believe, right? Oh, whoa. No. Octave slow. Okay, so this should take like 15 seconds again or something. 14 seconds, 12 seconds, I don't know. Oh, I'm bored. Okay. Yeah, so fprintf works in both. So that's the kind of thing you have to do here. So this is a script that'll work, but you would have to average by hand. This is a script that would work, but it just works. Okay. And so in part A, you're actually just running this. This is my code. Okay. Your code for bubble sort is what you're going to be running here. Okay. Now, something I want to be clear about, actually, I think I'm going to edit this probably before you get started on it to say this, but you better make sure your bubble sort works before you're doing this, okay? And yeah, there's no use timing code that doesn't work. So I think I'm going to add like another problem up here where you test your code. But yeah, so you're just timing both of those, and then there you go. Once you're done with that, then what you're going to be doing is we're going to be looking at sequences, and we're going to cover that in a separate lecture because we should have been doing this for an hour so far. So we will do that. Yeah, so I think that's it for right now. We'll talk about sequences in the next lecture. Yeah, have a nice day. So this homework is going to be due in less than 2 weeks. Actually, the end of next week and a half. Okay, so get started on it soon. It's not very much work. And if you work on it on this Friday and next Friday, you should be able to turn it in. Okay, so that's it. I'll talk to you guys later.